Hello, welcome to my first video for Nightly Review 22. This is what it looks like. It's blue, it says KR number 22, and we're going to start on Monday. So please go ahead and grab Monday. They want us to find an equivalent fraction for 5/9 and for 10/12. To find an equivalent fraction, you just need to either reduce the fraction or multiply the top and bottom by the same number. It's easiest for me to multiply the top and bottom by the same number, and it's probably easiest if you do one you know, like 2, 5, or 10. I'm going to go ahead and do 10 because I think that's easy. So whatever I do to the top, I do to the bottom. 5 times 10 is 50. 9 times 10 is 90. There's one equivalent fraction. Do the next one by yourself. Pick a different number to multiply. Alright. The next one on Nightly Review 22 is adding. We have 72,809 plus 49,449. Now adding is easy stuff, so this you should be able to do along with me. 9 plus 9 is 18, carry the 1. 1 plus 0 plus 4 is 5. 8 plus 4 is 12, carry the 1. 9 plus 2 plus 1, 12, carry the 1. 4 plus 7 plus 1, and you get 12. So we get the answer of 122,258. Let's move on to the number 3. It takes Cindy 3/4 of an hour to complete a puzzle. How many puzzles can Cindy finish in 3 hours? Well, it takes 3/4 of an hour for one puzzle. Now we have 3 puzzles. This is just like the ratio that we made a while back. How do we go from 1 to 3? We multiplied by 3. Whatever I do to one side of my ratio, I must do to my other side of the ratio. So I have to multiply by 3. So we just take 3/4 times 3. You can put it over 1. 3 times 3 is 9. 4 times 1 is 4. But we can't leave it like that as 9/4 hours. We can make this into a mixed fraction. We do that by thinking about how many times 4 can go into my numerator up here, 9. Well, I know 4 times 1 is 4. 4 times 2 is 8. That's as close as I can get to 9. So I know it goes into it 2 times. The bottom number or denominator of my fraction always stays the same. And 4 times 2 is 8. 9 minus 8 leaves me with 1. So it would take 2 1/4 hour to complete 3 puzzles. Have fun, Cindy. The next one you have to complete is a long division one, and I know how much we love long division. But luckily, we start off with a pretty easy long division. We're dividing by 20, which we already know how to do. We can count by 20s by going 20, 40, 60, 80, 100. I'm going to stop there because you probably know. So first things first, our rules for long division, D, M, S, V. Divide, multiply, subtract, bring down. 20 does not go into 8 because 20 is bigger than 8. However, 20 can go into 80. How many times? 20, 40, 60, 80. So 4 times. 4 times 20 is 80, and then we do our next step of subtract. 80 minus 80 leaves me with 0. Then I have to bring down my 2. 20 cannot go into 2 because 20 is larger than 2, so we'll put a 0 on top and bring down the 9. 20 goes into 29 only one time because 1 times 20 is 20 and 2 times 20 is 40. 1 times 20 is 20, and then we subtract. 9 minus 0 is 9. 2 minus 2 is 0. I'm out of numbers, but I have some left over, which means I need to add a decimal and bring down a 0. We're in 6th grade now, so we don't use remainders. How many times, now we're on our divide step, how many times can 20 go into 90? 20, 40, 60, 80, 100. So 100 is too much, which means we have to multiply 20 by 4 to get us to 80. Now we subtract 90 minus 80 is 10. Now we have to bring down another 0. How many times can 20 go into 100? 20, 40, 60, 80, 100. So 5 times. 5 times 20 is 100. 100 minus 100 leaves us with 0. There are no more numbers to bring down. We've gotten to 0, which means 8,029 divided by 20 is 401 and 45 hundredths. The next one to complete on our nightly review in the Monday column is a simple subtraction, but with decimals. So we need to remember when we're subtracting with decimals, we need to line up the decimals at the decimal point. So 128.04 minus, here's my decimal, so make sure we line our decimals up, and then we can go ahead and throw a placeholder 0 in there. Now it's time to subtract. You can't take away 7 from 0, so you have to go next door and borrow. The 4 becomes a 3, and the 0 becomes a 10. 10 minus 7 is 3. You can't take 3 away from 8, so you need to borrow. But you can't borrow from a 0, so you need to borrow from the 8. 8 becomes a 7. 0 becomes a 10. 10 becomes a 9, so 3 can become a 13. 13 minus 8 is 5. 9 minus 2 is 7. Bring down the decimal. We can't take 8 away from 7 because 7 is smaller than 8, so we need to borrow from the 2. 2 becomes a 1. 7 becomes a 17. 17 minus 8 is 9. 1 minus nothing is 1, and 1 minus nothing is 1. So we get 119 and 753 thousandths. A lot of us, for this next one, have forgotten what LCM stands for. LCM stands for least common multiple, which means the smallest multiplication answer that you can have. So just think about your times tables with this. We need the LCM of 3 and 8. So let's write out our 3 times tables. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 16, or 12, what am I saying? 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. And 3 times 8 is 24. Now let's write out our 8 times tables. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. Now look and find the numbers that they have in common. When you keep going on forever and ever, they'll have many, many numbers in common. But since it's the LCM, we just need the least common multiple. The only number I see here that they have in common is 24, which means the least common multiple of 3 and 8 is 24. The next one is find the missing number of each rate. So we have 2/10 is equal to 1 over question mark. And we have 4/16 is equal to 1 over question mark. This is the opposite of finding the equivalent fraction. Before we had to multiply to make an equivalent fraction. This time, since we're going from bigger to smaller, we're dividing. So 2 divided by what number is going to give us 1? If you forgot, any number divided by the same exact number will always give you 1. So 2 divided by 2 is 1. Whatever I do to the top of my ratio, I must do to the bottom. 10 divided by 2 is, or if you can't remember divide, 2 times what number gives you 10? 5. Looking over here, how do you go from 4 to 1? You got smaller, so you divide by the same number. 4 divided by 4 gives you 1. Whatever I do to the top, I do to the bottom. 16 divided by 4 is, or 4 times what number gives me 16? 4. Alright, this next one we have a bit of a word problem. Louis has a cooler filled with cans of soda. For every 5 cans of Coke, there are 3 cans of Sprite. Notice I've already written this down because I know this is key information I'm going to need to know to solve. If there are 25 cans of Coke, how many cans of Sprite are there? Just like the problem we just did, we have to look and see how we went from 5 to 25. Notice our numbers got bigger this time, which means we had to multiply to get there. 5 times what number gives us 25? 5. Whatever I do to one side of my ratio, I must do to the other side. So 3 times 5, which is 15. So if there are 25 cans of Coke inside that cooler, there are 15 cans of Sprite. The last one on the Monday column is what percent of 24, or is 24 of 40? And they have this nice little drawing for you. So obviously all of these blocks together make up 100%. And they each have 4 in there. They want to know what percent of 24 is 40. Well, 24 would be 4, 8, 12, 16, 20, 24, which they already have written for us. All these put together equal 40. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes that add to 40. Each one is equal to 4. So if 10 boxes all add up to 40, that means each of these boxes is worth 10%, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 create my 100% umbrella here. So how many boxes did I use here to get to 24? 10, 20, 30, 40, 50, 60. Which means then that 24 is 60% of 40. Alright, so now we're working in the Tuesday column. And the first one for Tuesday is an order of operations. We have 105 minus 7 squared plus 72 divided by 9. Before we even get started on this, let's review our order of operations, which is PEMDAS, parentheses, exponents, multiply or divide, add or subtract. So first things first, I can see here that there are parentheses. I have parentheses right here for 72 divided by 9. If you don't know your division, grab a multiplication chart, look in the 9 column until you find the 72. 9 times what number gives you 72? You should say 9 times 8 gives you 72. Then we copy the rest down. There are no more parentheses, so I'm done with that step, and I'm now on my exponent step. I have an exponent right here for 7 squared, which means I need to multiply the number 7 2 times. 7 times 7 is 49, and I bring the rest down. I'm done with my exponent step. Looking here, I see there is no multiply or divide, so I'm done with that step too, and I'm now at add or subtract. Looking this way, the first one I run into is subtraction. I have 105 minus 49. If you need to stack them on the side, go ahead and do that. You can't take 9 away from 5. Borrow. 15 minus 9 is 6. 9 minus 4 is 5. Bring down your plus 8. So now we're at 56 plus 8, which is 64. The next one we have to do is a super easy subtraction problem. We have 884,284 minus 349,407. Well, let's subtract. 4 minus 7 you cannot do, so you must borrow from the 8. The 8 becomes a 7, and this 4 becomes a 14. 14 minus 7 is 7. 7 minus 0 is 7. I cannot do 2 minus 4, so I must borrow from the 4. 4 becomes a 3, 2 becomes a 12. 12 minus 4 is 8. I can't take 3 away from 9, so I must borrow from the 8. 8 becomes a 7, 3 becomes a 13. 13 minus 9 is 4. 7 minus 4 is 3. 8 minus 3 is 5. So we get 534,877 for the second one on Tuesday. The next one on the Tuesday column is dividing fractions. We have 6 divided by 2/7. Well, it may have been some time since we divided fractions. Have no fear, because there's one restaurant that we always go to. We go to KFC to solve these. K means we keep, so I'm going to have to put my 6 over a 1 to remember that. F means flip division to multiplication. C means to change, so our 7 goes on top and our 2 goes on the bottom. Now we just multiply across. 6 times 7 is 42. 1 times 2 is 2. But we can't leave it like this. We can reduce this fraction. Actually, it won't even be a fraction. 2 goes into 42 a certain amount of times. If you can't remember, let's go ahead and divide. 2 goes into 4 2 times. 2 times 2 is 4. Subtract. Bring down. 2 goes into 2 1 time. Subtract. You're done. So 42 divided by 2 is 21, which will be the answer to 6 divided by 2/7. Let's move to the next one. Number 4 says, Kevin makes $78.37 one day of work. They want to know about 7 days. Well, if we know this is 1 day and we want to know 7, what should we do? We could add this 7 times, but that might take a while. Instead of the repeated addition, we can just do multiplication. 7 times 7 is 49. 7 times 3 is 21, plus 4 is 25. 7 times 8 is 56, plus 2 is 58. 7 times 7 is 49, plus 5 is 54. Now we need to put our decimal in. We see with our multiplication that the decimal point has 2 numbers behind it, so we move it over 2. Which means Kevin would make $548.59 in 7 days. Next, we need to find the product. Product means multiply. So they give it to us like this. I'm going to go ahead and change it and stack them up. So 1,389 times 6.58. Now with decimals, I know when I multiply with a decimal, I should just wait until the end to deal with my decimal. Ignore it for now. So let's start with my ones place, the 8. 8 times 9 is 72, carry my 7. 8 times 8 is 64, plus 7 is 71, carry my 7. 5 times 3 is, 8 times 3, sorry. 8 times 3 is 24, plus 7 is 31, carry my 3. 8 times 1 is 8, plus 3 is 11. Now I cross off my old, add a placeholder 0, and now I'm moving on to 5. 5 times 9 is 45, carry my 4. 5 times 8 is 40, plus 4 more is 44, carry my 4. 5 times 3 is 15, plus 4 more is 19, carry my 1. 5 times 1 is 5, plus 1 is 6. Cross off my old, add another placeholder 0 since we're now moving into our third place value of 6. 6 times 9 is 54, carry my 5. 6 times 8 is 48, plus 5 more is 53, carry my 5. 6 times 3 is 18, plus 5 is 23, carry my 2. 6 times 1 is 6, plus 2 is 8. Now I can move to my addition step and add all these up. 2 plus 0 is 2. 1 plus 5 plus 0 is 6. 1 plus 4 is 9. 1 plus 9 plus 3 is 13. 1 plus 1 plus 6 plus 3 is 11. 8 plus 1 is 9. I'm not done yet though. I knew in my original problem I had 2 numbers behind the decimal, so I must move my decimal 2 places in, which leaves me with an answer of 9,139 and 62 hundredths. The next one we have to do is use the distributive property to express 27 plus 60. The distributive property is when we have a number on the outside of a set of parentheses, and we know if we use this number to multiply it into the set of parentheses, I'll get exactly what my original equation was. So first things I need to think about are numbers that go into 27 and 60, so I can fill them in here, so I can fill it in. I know 3 will go into both of them, so let's go with 3. 3 times what number will get me 27? 9. To get to 60 is a little more complicated. So if you need to divide, that's fine. 3 goes into 6 2 times, subtract, bring down, 3 goes into 0 0 times. So I can express 27 plus 60 as 3 times the quantity of 9 plus 20. The next one's a word problem. To make a trail mix, you must have 4 cups of pretzel and 2 cups of bread chips. Notice I already wrote that information down because I know it's going to be key for solving this problem. They want to know what the ratio is of pretzels to bread chips, which I already just wrote, 4 pretzels to 2 bread chips. However, we can reduce this ratio. There's a number that goes into both 4 and 2, and that magic number is 2. 2 goes into 4 2 times. 2 goes into 2 1 time. So my reduced ratio would be 2 cups of pretzels to 1 cup of bread chips. Now this next one is to complete the table. So in this table of paper and pencils, they have for 5 papers, there are 4 pencils. For 10 papers, there are 8 pencils. For 15 papers, there are question mark pencils. And for 20 papers, there is question mark pencils. We need to find our 2 question marks. This is just like seeing what we're doing to our original ratio to get to these new numbers. So if you look from 5 to 10, how do you go from 5 to 10? You multiply by 2. 5 times 2 is 10. Whatever you do to one side, you do to the other. 4 times 2 is 8. So whatever I multiply on this side, I'll multiply on that side to get my 2 question marks. 5 times what number gives me 15? 5 times 3. 5 times what number gets me 20? 5 times 4. So now let's do the same to the pencil side. 4 times 3 is 12. 4 times 4 is 16. Now you finished your chart. The last one on Tuesday is a word problem, and I had to pause the video to figure it out myself for a second. So if a board game was originally $25 and it's on sale for $18, what's the discount? Before I can do anything, I need to figure out what's the difference between 25 and 18. I'm getting a savings of $7. 25 minus 7 will give me 18. So what percent is $7 of 25? We find this by dividing. So we'll put 25 on the outside and 7 on the inside. Because remember, when we get percents, we usually find them in decimals first, and then we move our decimal place. 25 cannot go into 7, which means I need to add a decimal and put a 0. I like to think of 25 like quarters. How many quarters fit into 70 cents? 25, 50, 75. So 75 is too many, so 2 quarters. 2 times 25 is 50. Then we subtract. 0 minus 0 is 0, and 7 minus 5 is 2. Bring down another 0. So now we have $2.25. How many quarters goes into $2? 25, 50, $75, $1, $1.25, $1.50, $1.75, $2. That's 8. 8 times 25 is 200. And we get to 0. Well, now we have our decimal. When we're converting a decimal into a percent, you could use your Dr. Pepper method. We're going from a decimal to a percent, which means we need to move our fraction 2 places over, or move our decimal 2 places over, to give us a savings of 28%. Alright, we're going to keep on going along, and now we are on the Wednesday column. Wednesday. Alright, the first one on the Wednesday column is writing fractions in simplest form. So we have 25 over 7 and 39 over 51. First things first, let's take a look at this 25 over 7. This is an improper fraction, which means we're going to be turning this into a mixed number, which means one big number on the outside and a fraction. How many times can 7 go into 25? 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28. So 4 is too big, so it goes into it 3 times. So that's going to be our large number on the outside of the fraction. Our bottom number always stays the same, so 7 will stay as 7. 3 times 7, we said, is 21. So 25 minus 21, well, if we count up from 21, that's 22, 23, 24, 25. So 4 left over. So in simplest form, 25 over 7 is 3 4/7. This one will be a little different because it's not an improper fraction. We need to find a number that goes into both of these to make it as small as it can go. Now this is probably not something that you guys will think of right away because we don't usually go this far in our multiplication tables. But 3 will go into both of these numbers. This is how I like to remember it. If I add my two numbers together and they give me a multiple of 3, I know 3 is going to go into it. 3 plus 9 is 12, 5 plus 1 is 6, which means 3 is going to be able to go into both of these numbers. We just need to find out how many times. 3 goes into 3 one time. 1 times 3 is 3. Subtract, bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. We get down to 0, which means our top number when we divided by 3 gave us 13. Now let's find the bottom number. 3 goes into 5 one time. 1 times 3 is 3. Subtract. 5 minus 3 is 2. Bring down the 1. 3 goes into 21 7 times. 7 times 3 is 21. We get down to 0. So 51 divided by 3 is 17. So that's our fraction in simplest form. The next one we have is multiplication. We have 4,930 times 184. So let's go ahead and start with our ones. 4 times 0 is 0. 4 times 3 is 12. Carry the 1. 4 times 9 is 36. Plus 1 is 37. Carry the 3. 4 times 4 is 16. Plus 3 more is 19. Cross off the old. Add your placeholder 0 and start with that 8 now. 8 times 0 is 0. 8 times 3 is 24. Carry the 2. 8 times 9 is 72 plus 2 is 74. Carry the 7. 8 times 4 is 32 plus 7 is 39. Cross off the old, move to that last place with a double placeholder, since we're now in the hundredths spot. 1 times 0 is 0. 1 times 3 is 3. 1 times 9 is 9. 1 times 4 is 4. Now let's add it up. 0, 0, and 0 is 0. 2, 0, and 0 is 2. 7, 4, and 0 is 11. Carry the 1. 1, 9, 4, and 3 is 17. Carry the 1. 1, 1, 9, and 9 is 20. Carry the 2. 4 plus 3 plus 2 is 9. We get 907,120. All right. The next one is a word problem. It says that Jamie has 7/10 of a pound of chicken. So 7/10 of chicken. If he's going to split the chicken with 3 people, how much does each person get? Well, to solve this, we need to figure out what we're splitting up first. We're obviously dividing. We just have to figure out what are we dividing up. Are we dividing up the chicken or the people? We're going to be dividing the chicken. I hope you didn't say we're dividing the people, because that means we're cutting people up, and that's not cool. So we have 7/10 divided by 3. Now let's go ahead and K, F, C. K means we keep 7/10 as it is. F means we flip division to multiplication. C means we change. Before we technically had 3 over 1, so now we go ahead and change it to 1 over 3, and we multiply across. 7 times 1 is 7. 10 times 3 is 30. We cannot reduce this fraction. There is no number that goes into 7 and 30, so that's how much chicken each person gets, 7/30. The next one we have is long division. We have 15 and 28,395. Now, if you use your agenda, the multiplication chart in your agenda goes all the way to 15. So you could solve this by using that. I'm going to be using the guess and check method on the side, because if you take a test or for TN Ready and you have to do this, you may not have that multiplication chart available for you. So first things first, how many times does 15 go into 2? It doesn't. It's too small. But how many times can 15 go into 28? Well, let's guess and check. 15 times 1 is obviously 15. 15 times 2 is, well, 2 times 5 is 10, carry the 1. 2 times 1 is 2, plus 1 is 30. 30 is too much, which means 15 is going to go into 28 one time. 1 times 15 is 15. Let's subtract. Remember, this is our DMSB. 8 minus 5 is 3. 2 minus 1 is 1. Bring down another 3. Now we need to know how many times 15 goes into 133. Guess and check method. I'm going to try 6 and see how close I get with 6. 6 times 5 is 30. 6 times 1 is 6, plus 3 is 90. I can get closer. Let's try 8. 8 times 5 is 40. 8 times 1 is 8, plus 4 is 120. That's as close as I'm going to get. Thinking about it in my head, if I were to add 15 more to this, that would put me at 135, which is too big for this. So it goes into it 8 times. And we just did our math over here. 8 times 15 is 120. And now we subtract. 3 minus 0 is 3. 3 minus 2 is 1. 1 minus 1 is 0. Now we bring down our 9. Well, let's try 15 times 9 and see if we can get any closer than we could with 133. 9 times 5 is 45. Carry the 4. 9 times 1 is 9, plus 4 is 135. That's pretty darn close, so it goes into it 9 times. 9 times 15 is 135. Let's subtract. 9 minus 5 is 4. 3 minus 3 is 0, and 1 minus 1 is 0. Now we'll bring down the 5. Well, 15 times 2 is 30. Let's try 15 times 3 and see if we can get to 45. 3 times 5 is 15, carry the 1. 3 times 1 is 3, plus 1 is 4. That's what we're looking for. So 3 times 15 is 45. We subtract. We get to 0. There's no other numbers to bring down, which means 28,395 divided by 15 is 1,893. Make sure you have all this work down. Pause the video if you need to. Next one is finding the sum. We have 840 and 89 hundredths plus 928. The important thing here is this number has a decimal, so we need to line our decimals up. So if we write 840 and 89 hundredths, now we need to keep in mind that decimal. This number doesn't have a decimal, so we're going to put it right before where a decimal would be if we were to add one. Then we can go ahead and add one, put some zeros there to make it easier for us while we're adding. 9 plus 0 is 9. 8 plus 0 is 8. 0 plus 8 is 8. Bring down my decimal. 4 plus 2 is 6. 8 plus 9 is 17. We get a total of 1,768 and 89 hundredths. The next one is finding the GCF of 72 and 36. So you need to remember what GCF stands for. GCF stands for greatest common factor. So factors are numbers we use when we're multiplying. So this is the opposite of least common multiple. With least common multiple, we wrote our answers down in multiplication problems. With GCF, we're writing our factors down. So for 72, we obviously know that 1 times 72 is going to give us 72. Now let's move to 2. 2 will obviously go into 72 because it's an even number. Well, let's find out how many times it will go into 72. 2 goes into 7 3 times. 3 times 2 is 6. Subtract. Bring down. 2 goes into 12 6 times. So 2 times 36 will give me 72. Now let's move on to 3. I'm going to use my trick that I learned when I was in elementary school, that if the two numbers, when you add them together, is a multiple of 3, 3 will go into it. 7 plus 2 is 9, which means 3 is going to go into 72. We just need to see how many times. 3 goes into 7, 2 times 3 is 6. Subtract, bring down, 3 goes into 12, 4 times. 12 minus 12 is 0. So 3 times 24 gives me 72. Now we need to think about 4. Will 4 go into 72? Well, let's find out. 4 goes into 7 one time. 1 times 4 is 4. 7 minus 4 is 3. Bring down the 2. 4 goes into 32. 8 times 4 is 32. Which means that yes, 4 does go into 72 18 times. So we'll write down 4 and 18. 5 will not go into 72 because it does not end in 5. 6 does go into 72. If you remember your multiplication fact, 6 times 12 gives you 72. 7 does not go into 72, but 8 does. 8 times 9 gives me 72. Since these numbers are right next to each other, we know we're done. Those are all the numbers that go into 72. Those are all of our factors. The other number we need to define is 36. So we obviously know 1 and 36. 36 is an even number, which means 2 will also go into it. Let's find out how many times. 2 goes into 3 one time. 2 times 1 is 2. 3 minus 2 is 1. Bring down the 6. 2 goes into 16 8 times. 8 times 2 is 16. So 2 times 18 gives me 36. 3 goes into 36. That's a multiplication fact I should know. 3 times 12 gives me 36. 4 also goes into 36. 4 times 9. 5 will not go into 36 because 36 does not end in 0 or 5. But 6 does. 6 times 6. But we only have to write that 6 once. Since 6 and 6 make 36, we're done. Those are all the numbers that will go into 36. So now we have to look for the greatest common factor. So the greatest number they have in common. You can see here they have a lot in common. But the biggest number they have in common is 36. So the GCF of 72 and 36 is 36. Alright, the next one is the ratio of beach balls to goggles. So here are my beach balls. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 beach balls. Mine will look like glasses, but I'm not an art teacher. 1, 2, 3 goggles. But we need this in simplest form. There's a number that goes into both 9 and 3. That number is 3. So let's divide each by 3. 3 goes into 9 3 times. 3 goes into 3 1 time. So the simplified ratio is 3 to 1. Let's move to the next one. Jesse competes in hot dog eating contests. He can eat 32 hot dogs in 8 minutes. Notice I already wrote this as a ratio or a rate because I know we're probably going to have to do something with this rate. How many hot dogs can he eat in 12 minutes? So this time they want to know how many hot dogs for 12 minutes. Remember, we need to keep our units the same. If we put hot dogs on top here, hot dogs on top. Minutes on the bottom, minutes on the bottom. Well, we need to figure out how we go from 8 to 12. Well, I don't know about you, but I don't think 8 goes into 12 evenly. If we want to find something evenly to make this easier for us, we need to look at the 32 and 8 first. I know that 8 can go into both of these numbers. 8 goes into 8 1 time. 8 goes into 32 4 times. That's a little bit easier to get to 12. How do we go from 1 to 12? We multiply by 12. How do we go then? Wherever we do the bottom, we do to the top. 4 times 12 is 48. So in 12 minutes, Jesse can eat 48 hot dogs. That is crazy. The last one on the Wednesday column says, a group of 150 dancers are auditioning for a dance show. So there's 150 dancers. 62% trying out get cut. They don't make it. So they want to know how many dancers did not get it. So we need 62% of 150. We can do that by multiplying. However, when we multiply with a percent, we need to turn this percent back into a decimal. How do we do that? Dr. Pepper. We started with a percent, we're moving to a decimal, which means we're moving our decimal that way. So it becomes 62 hundredths. So now, let's do 150 times 62 hundredths to figure out how many dancers didn't make it. 2 times 0 is 0. 2 times 5 is 10. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Cross off the old. Put my placeholder. Moving on to the 6. 6 times 0 is 0. 6 times 5 is 30. Carry the 3. 6 times 1 is 6. Plus 3 more is 9. Now we add. 0 and 0 is 0. 0 and 0 is 0. 3 and 0 is 3. And then 9. Now before you say that's your answer, that is not our answer. If we started out with 150 dancers, there's no way we could cut 9,300 of them. Look back in your multiplication problem. We multiplied with a decimal. There were 2 numbers behind the decimal, which means we need to move our decimal place 2 places over. That makes a lot more sense. This time, 93 dancers got cut. Sorry, guys. Try out for the next one. Alright, home stretch, we're on the last column, the Thursday column. And our first one is an order of operations. 3 cubed minus the quantity of 60 divided by 10, closed quantity, plus 8. Before we start solving, let's review our order of operations. Parentheses, exponents, multiply, divide, add, subtract. First thing up is parentheses, right there. 60 divided by 10. So 10 times what number gives me 60? 10 times 6. Bring the rest down. Done with parentheses, on to exponents. 3 cubed. So 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Bring the rest down. We're done with exponents. We're on the multiply divide step. There is no multiply divide, so we're done with that. We're at add and subtract. First thing up is 27 minus 6, which is 21. Bring down the plus 8. 21 plus 8 is 29. The next one is a long division one, which I know you all love. We have 31,940 divided by 44. So, just like the previous ones I did, I'm going to be doing guessing checks because my multiplication charts and tables don't go all the way to 44. So, I'm going to do some guessing and checking. So, let's get started. 44 cannot go into just 3. 44 cannot go into just 31. Which means we have to look at 44 and 319. So let's do some guessing and checking. Let's try 5. 4 times 5 is 20, carry the 2. 5 times 4 is 20, plus 2 is 22. We could probably get a lot closer than that. Let's try times 8. 8 times 4 is 32, carry the 3. 8 times 4 is 32, plus 3 is 35. Too big. Let's try smaller. I'll try 6. 6 times 4 is 24, carry the 2. 6 times 4 is 24, plus 2 is 26. Thinking about it in my head, if I were to add 44 more, 4 plus 4 is 8, 6 plus 4 is 10, carry the 1, 2 plus 1 is 3, so I would have 308, which is closer. So I'm going to go ahead and write out that times 7 really quick. 7 times 4 is 28, carry the 2. 7 times 4 is 28, plus 2 is 30. That's as close as we're going to get. So let's put a 7 above that 9. Remember DMSB. I'm not going to write it right there actually because this is going to go on. So 7 times 44 is 308. 9 minus 8 is 1. 1 minus 0 is 1. 3 minus 3 is 0. Bring down the 4. So now we need to see how many times 44 can go into 114. Well, 5 is what we've tried before, so let's try something smaller. Let's try 3. 3 times 4 is 12. Carry the 1. 3 times 4 is 12. Plus 1 is 13. That's too much, which means it's going to have to be 44 times 2. 4 times 2 is 8. 4 times 2 is 8. Put a 2 above that 4. 2 times 44 is 88. Now we'll subtract. We're going to have to borrow. 14 minus 8 is 6. Borrow. 10 minus 8 is 2. Bring down that 0. How close can we get to 260? Well, we have 264 over here with 6. That's too much, so we got to go back to 5. 5 times 44 is 220. We solved that over here earlier. 0 minus 0 is 0. 6 minus 2 is 4. But we cannot be done. We need to bring down another 0, but before we do that, we add a decimal. Sorry about this. I'm going to switch to black so that way that blob doesn't confuse you later. Alright, so we're bringing down that 0. We haven't figured out how close 44 can get to 400 yet, because the biggest we tried so far is 8. So let's try 9. 9 times 4 is 36. Carry the 3. 9 times 4 is 36. Plus 3 is 39. So that's as close as we're going to get to 400. So let's go ahead and put that 9 on top. 9 times 44 is 396. Subtract. Well, 96 is only 4 away from 100, so 4. Bring down a 0. 44 cannot go into 40, so we need to put a 0 here and bring down another 0. 400 is what we had before, which means we're going to have a repeating decimal. We're going to keep having to subtract by 396 and keep having to bring down more zeros forever and ever and ever. So our final answer we can say is 725 and 9 hundredths repeating, or 90 hundredths repeating, or 9 tenths. It's going to repeat forever and ever and ever. Alright, I'm going to switch back to pink now. The next one is a division of fractions again. So we have 7/9 divided by 4. Easy stuff. K, F, C. K means to keep, 7/9 the same. F means to flip, division to multiplication, and C means to change the order of my numbers, so we have 1/4. And then we multiply across. 7 times 1 is 7. 9 times 4 is 36. Can 7 and 36 have any numbers in common? They do not, so we leave our fraction as that. Alright, next one. On 34 acres of land, I'm just going to put 34 land, there are 8,942 trees. If the trees are spread out evenly, how many trees per acre? Well, if we're spreading something out evenly, it means we're putting it into equal groups. We know when we're putting something into equal groups, that means we're dividing. So let's go ahead and divide. We have 34. Actually, I'm going to write it this way, because we are going to long divide again. 8, 9, 4, 2. So let's start guessing and checking some numbers. 34 cannot go into 8, but 34 can go into 89. Let's find out how close we can get. Let's try times 2. 4 times 2 is 8. 2 times 3 is 6. Let's try times 3. 3 times 4 is 12. Carry the 1. 3 times 3 is 9. Plus 1 is 10. So 3 is too big, so we have to go with 2 times. 2 times 34 is 68. Let's subtract. 9 minus 8 is 1. 8 minus 6 is 2. Bring down the 4. Let's guess and check another number. Let's try 8. 8 times 4 is 32. Carry the 3. 8 times 3 is 24, 25, 26, 27. Too big. Let's try 6. 6 times 4 is 24. Carry the 2. 6 times 3 is 18. Plus 2 is 19, 20. That's as close as we're going to get for sure. So we'll put a 6 above that 4. 6 times 34 is 204. Let's subtract. 4 minus 4 is 0. 1 minus 0 is 1. Bring down the 2. Well, we already solved earlier how we can get to 102. 34 times 3 gives us 102. So a 3 on top. Sorry, I'll do it in the pen again since I messed up. 3 times 34 is 102. 102 minus 102 is 0, which means there are 263 trees per acre of land. All right. Every 3 days, Seth goes to the store. So Seth goes every 3 days. His best friend Brian goes every 5 days. When are they going to bump into each other? To do this, we can use least common multiple to figure that out. If you remember from Monday's column, least common multiple is the answers to our multiplication problems, and we find the smallest one they have in common since least means small. So let's do that for our 3 and 5. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 3 is 15. Let's move to 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. I see right here they have 15 in common. 15 is the least common multiple, which means after 15 days, Seth and Brian will finally run into each other in the candy aisle at Kroger. All right. Anthony purchased 4 burgers for $4.60. Based on this rate, how much does each burger cost? Well, when we have a rate, we know we need to divide. So if we divide this, we can find out how much one burger costs. So let's do that. Remember to bring your decimal up on the top as well. How many times does 4 go into 4? Once. 1 times 4 is 4. Subtract. Bring down the 6. 4 goes into 6. 1 time. 1 times 4 is 4. Subtract. 6 minus 4 is 2. Bring down the 0. 4 goes into 20 5 times. 5 times 4 is 20. We get to 0. Now before you say the answer is 1.15, remember we were talking money up here. So one burger equals $1.15. Next one, we had a little table with marbles and bags. So if you have one bag, there are 8 marbles in it. 16 marbles are in 2 bags, 24 in question mark, and 32 in question mark. Well, this is like the table we had on the Tuesday column. We look and see what one side's doing, and we do it to the other side as well. How do we go from 8 to 16? We multiply by 2. That's what we did here, obviously, because 1 times 2 is 2. So how do I go from 8 to 24? I multiply by 3. How do I go from 8 to 32? I multiply by 4. Whatever I do to this side, I do to the other side. 1 times 3 is 3. 1 times 4 is 4. Last problem in our nightly review. Nancy purchased bed sheets for $36. They were 25% off. What was the original price of the bed? For me, the easiest way to solve this is to draw a picture. So, just like that 1 on the other side. Now, I know 25%. To get to 100%, I can split it into 4 groups. So we have 4 equal groups. And this would be 25%. Now, it says it's $36 at 25% off, which means it doesn't mean that the price is 25% of the price is 36. The remaining percent is 36, which would be 75, right? Because 75 plus 25 gives us our full 100. So all of these 3 boxes need to add up to 36. So we need to divide 36 evenly in 3 boxes. 3 goes into 3 1 time. We subtract. Bring down the 6. 3 goes into 6 2 times. 6 minus 6 is 0. So that means each of these boxes will be 12 to get us to 36. Well, if all of these are 12, that means this one has to be 12 as well. Like I said, we knew that these 3 boxes gave us 36. So if we add 12 more to our 36, we get a total price of $48. So it originally cost us $48 to buy those bed sheets.